Hello everyone, welcome to Physics Wallah guys. Hope you all are doing well and your preparation is going to up to the mark and you are preparing well for your GATE examination. Not only signal system, different subjects also. Now guys, this is the comprehensive course and I welcome you all in this beautiful course in which we are dealing the complete signal system in a very detailed manner. Okay, so those who haven't covered this course till now, then please go and cover all the lectures. I have taken all the lectures in the live manners and the classes is daily live from 7 to 8:30. Okay, those who don't know. The point is that in this class we are going to cover the one of the most awesome concepts. Okay, and here let me check first audio and video. If my audio, voice and audio is clear, then please let me know. Let me check here also. Yes. Okay, fine. So I think my voice and audio is everything is clear. So let's start the class now. Let me introduce first myself. My name is Pankaj Singh. I have in total 15 years of teaching experience in this GATE field. And that is, we are dealing this course in a comprehensive manner. So let's start now. In the last class we have covered, that is the topic, which is first is that is the operation on signal. We have covered this topic in detailed manner in which we have covered the mainly x-axis operations. So x-axis operations, that is time shifting, time scaling and time reversal. We have covered each and every topic now, and we have just introduced second topic we have introduced, that is the elementary signal. Okay, so elementary signals, I have just give you a basic definition that what do you mean by the word elementary. See here, I told you in the last class that elementary signals are those signals from which high order signals can be derived, and the elementary signal that we are going to cover in this course is this one. See, this is a step function. Then we have impulse function. We have to cover this impulse function. Okay, and then we will cover a ramp function, and then we will cover our exponentials. So we will cover these all exponential signals, exponential, in which we will cover that is a real exponential and complex exponential. Okay, good evening Vaishnavi. Fine. So these are the topics that we are going to cover in today's class. What we will cover the step function. Let's start. Okay, so we will cover the step function in detail in today's class. Let's start now. Now what do you mean by the word step? See here, step function. See here, consider a signal. Let's consider suppose we have a signal which is this one. Okay, and what I am saying is that we have a signal, let's say this one, which is 0 up to this time, and suddenly it jumps to some finite value let's say this, and then it maintain its value till 1. Suppose we have this signal, this is nothing but my 0 for t is equal to 0, we will say like this. Okay, for t less than 0, the function is 0. At t is equal to 0, function jumps to a certain height. Let's consider this height as a, and then after that it will maintain its height to for t greater than 0. For t greater than 0. What we will say this one? See here, this function we will say that it is a for t greater than 0 and is 0 for t less than 0. See here, there is a finite discontinuity. There is a finite discontinuity at this point. See, at this point there is a finite discontinuity because the function suddenly jumps at this particular point t is equal to 0. Now, what is the nature of this discontinuity? If you want to find out the value at the point of discontinuity, then there is a very famous phenomena that we will cover in the Fourier series, that is known as the guessed phenomena. And it says that if you want to take the functional value at the point of discontinuity, then it is the average of value before and after discontinuity. Exactly value is undefined, because if you take the value to be, that is the first derivative of this function at this point t is equal to 0, then the first derivative of function is not defined. We will say like this. So what I am saying is that the functional value is, say, if we will say that it is a average of a plus 0 divided by 2, which is a by 2 at t is equal to 0. This is approximate value. Exact value is not defined. Approximate value. Very good evening. So what I am saying is that, see here, the value at point at discontinuity is nothing but my average of a value before and after. See, before at t is equal to, if you see, if you look here, then this is a t0 minus, t0 minus, and this is t0 plus, t0 plus, and we have to take the average of the value before and after discontinuity. We have to take the value of average here. 0 minus value 0, at 0 plus we have a value a. And how we will denote? We denote the function x of t. If this is x of t, then we denote this function x of t by aut, where a is a jump and ut is a step function. Ut denotes the step. Ut is a step function. Okay, so it is the function which is denoted by aut. If a is equal to 1, if we consider a to be equal to 1, let's say if a is equal to 1, then we have a function, okay, we have a function which is this one. This function, and this is 1. This value is 1. So that we call it to be the ut. This is ut. This we call it to be the ut. So ut is a function which exists at t is equal to 0. This is a function which exists at t is equal to 0 and before 0. So what you will say about ut? Ut is 1 for t greater than 0, 0 for t less than 0, and it's, what is the value? 1 plus 0 by 2 for at t is equal to 0. At t is equal to 0, this is the average value, average of before and after the function. So that's what the meaning of this function. We will call it to be the step 1. Now my question is that where you encounter this step function, that's the important thing. See here, you know that suppose we have a system like this. Suppose we have a system, and let us consider this to be a second order control system. Second order control system. And this is operated by, okay, let's consider suppose we have this one, a second order control system in which I have a switch here, and suppose for example a voltage source of, let's say, voltage source of 5 volt, let's say, is applied across this second order control system. You know that what do you mean by order, or let's say type of a control system? A control teacher will tell you that what kind of systems we have when we deal with the second order systems. Now if suppose switch is closed, the switch is ideal and the switch is closed at t is equal to 0, then second order means we have a 2 energy storing element. Let's say C and L are the 2 energy storing element which are present here, and this system is having a highest power of 2. Now the point is that, see here, if the 5 volt is applied across this system, then what is the response at the output of this one? See, suppose I am measuring the output here. You may take the output across the capacitor, you may take the output across the inductor, whatever. For capacitor you will observe a voltage, or for inductor you will observe a current. Then what kind of response that I will get here? See here, you know that the response that I will get is this one. See, the response is this one. This kind of response I will get. See, you have a response like this, depending on the, of course, this value. Now the point is that up to this part, see here, up to this part, we call this as see, we call this part to be a transient part. This I am calling it to be transient part, and this I am calling it to be the steady state part. Okay, so when a second order control system is subjected, when a second order control system is subjected to a, let's say, a uniform voltage source applied across t equal to 0, and when you close the switch, then the value, this value, let's imagine to be 5 volt, the value will not be suddenly equal to 5 volt. This means that at t, this is t is equal to 0, the t is equal to 0, the value suddenly will not be equal to 5 volt, but it will take some time, and we call this time to be a settling time. From the control concept you will know, or if you don't know, then you will know then when you cover this part. So this means that the time taken by a system to achieve its final value, we call it to be the transient part, and after that we have a steady state part. Though it will never settle, it will settle up to, let's say, 4.98 or 5.02, that depending on a tolerance band. So this means that, see, that the whole thing, this is what we say that it is a practical step. This is the practical step. Okay. That is, we never get, what is the ideal step then? The ideal step is this, see. The ideal step is this. This is the ideal step. This is the ideal step. So that the value start from t is equal to 0. Ideally, the value has to be, becomes a 5 volt the moment you close the switch. But it's not possible. See, it will take some time, some finite time, no matter how small this time will be, but it will take some finite time to reach its final value. So we will say that it has some transient here, some, let's say, some slag here, and that depends on the system, that is the speed, that how small will be that particular transient part is. But what I want to say is that practically this step is not possible. In practice, we always have this kind of things. And in our control systems here, so in our signal system, what I am saying is that instead of taking it to be the practical step in this way, we take the practical step to be in this way. See, we take the practical step to be in this way, like this. And after that, it will, let's say, maintain its constant value. See here. Okay. And this part, we call it to be, let's say, this part, we call it to be a this part, I'm calling it to be a dead zone. So this I am calling it to be dead zone. Dead zone, denoted by A. What is the meaning of dead zone? See here, this much time is required to reach its final value. This is the practical step. This is the ideal step. This is the ideal step. See, mind it that this would be your ideal step. This is your ideal step. Okay, this is your ideal step. But that is your practical step. This is your practical step. Okay. So my point is that you will never get a practical ideal step to be that the value, if you close the switch, then you will directly get the value. Let's assume a practical example. Suppose no matter how fast your pickup of a particular engine is, whether it will be any vehicle, whether it will be Lamborghini, a Jaguar, or whatever, no matter how fast it will attain to be the, let's say, top speed, but it will take some time. It will not like that if you ignite the particular engine and it will attain a speed of 100 RPM, let's say 100 miles per hour or 100 kilometer per hour. It will never reach like that. It will take some time, and that time is denoted by a dead zone. That's what the transient part of a system comes into the picture. Is it clear? So what I am saying is that, so these are the practical things, and these are the nothing but my ideal things that you encounter in your nothing but my course. So whenever I am saying that this is the step function, then the step function is actually this, but the practical step function is this one. Is it clear? We always have a practical step function in this form instead of this form. The same form is replicated in this form because we never take this as a function. Okay. So what I'm saying is that, see here, what I'm saying is that this kind of thing is very, very important. This kind of thing is very, very important. Okay. Now the point is that this is what a meaning of elementary is. This is what the meaning of the elementary is, and elementary signals having this kind of step functions we have. Now next is, let's say if we have a elementary function, and I'll told you that what is the step function, what is the modeling of elementary function, then let's play with the elementary function. what kind of, see here, let's take an example. Suppose we have a question. I'm saying that plot, let's take a plot which is a yt is equal to, okay, ut plus alpha, and yt is equal to ut minus alpha. Ut minus alpha. For example, I want to plot these two functions. For example, I want to plot these two functions, and this is what the ut plus alpha and ut minus alpha is. What is ut plus alpha? See here, it is the function. See, ut plus alpha is this function, okay, which is shifted to be, let's say, see, ut minus alpha is this one. See here, this is ut minus alpha. So this function is shifted by alpha factor. This function is shifted by alpha factor, and this is what the meaning of ut minus alpha is. Okay, what is ut plus alpha? Ut plus alpha will denote like this. See, this one. That's what the meaning of ut plus alpha is. So it's left shifted by the factor of alpha. It's left shifted by the factor of alpha. So this means that this value should be 1, this value should be 1, this value should be 1, and this value should be 1. Okay. Now the point is that, see here, listen carefully, that this ut plus alpha and ut minus alpha, ut plus alpha and ut minus alpha is the shifted version of this function. So suppose if this is the question number 1. Question number 2, if I am saying, question number 2, if I say AUT plus alpha minus, let's say T, let me say like this, AUT plus tau by 2 minus AUT minus tau by 2 is what my xt is, and I want to plot xt. Suppose, good evening, so AUT plus tau by 2 minus AUT minus tau by 2, AUT plus tau by 2 minus AUT minus tau by 2. So I want to plot xt. Okay, I want to, let's say, plot this function. Now the point is that, see here, listen carefully, this can be done by this function. See here, this is AU, see, this is the function which is tau by 2 minus, and it is AUT plus tau by 2. This is this function, AUT plus tau by 2. And what about this one? See here, this is a function which is let's say it starts at this value. Okay, so it is AUT plus tau by 2 and AUT minus tau by 2, like this. Okay, so this is a function which is AUT plus tau by 2, AUT minus tau by 2, and we have to subtract this function. See here, till minus tau by 2 up to minus tau by 2, you will say that this function is completely 0. This function is completely 0. From minus tau by 2, here somewhere is minus tau by 2. Here somewhere is minus tau by 2. From minus tau by 2 to tau by 2, this function is a, that is 0. But after tau by 2, both are a. So when you subtract, let's consider it to be a and this to be b. And when you, let's say, subtract a minus b, a minus b, what you will get? See, what you will get if you subtract both this function, then what you will get? You will get, don't you think that you will get this function? See, this function you will get. This function from minus tau by 2 to tau by 2, it is a. Look, it is the function. If you subtract both this function, then this step function will be cancelled after tau by 2, and it starts from minus tau by 2. So what I'm saying is that this will exist from, let's say, minus tau by 2 to tau by 2, and this is a, and hence this is a rect t by, this is a function, we call it to be a rect function. Okay, rect function, or we will say that it is a function which we call it to be the gate function. Gate function. So this is a rect function, this is a gate function, and denoted by a rect t by tau. A rect t by tau. Okay, so what I am saying is that this is a function which is denoted by a rect t by tau. And see here, what is the total height here? Total, if you look at the height and width, then this I am calling it to be, let's say, use this. This is a height, sorry, this is width, and that is height. So this is tau, and that is a. This is a. So you will write this as height rect t by total width. This is a representation of a certain function. So that is a very, very interesting and very, very important function, guys, because many times you have to find out the Fourier transform of this function. Sometimes directly they ask you the Fourier transform of this function. So this is what a general formal rect function is. For example, let's take an example on this. Example number 3. Suppose someone asks you plot rect t. This means that what? Here we have a equal to 1 and tau equal to 1. So total width is tau, and this is equal to 1. So we have to represent it by half width here, half width there. This means that, see here, this means that we have a function which is this one. Okay, and this is minus tau, minus half, this is plus half, and that value is 1. This is what my rect function is, rect t is. Now I am giving you one question, right, just now, example before here itself. Let's say plot, this is the example 4, plot 1 by t rect t minus, let's say, 0.5 by t. Suppose someone asks you this function. Let's plot this one. Come on, do it. 1 by t rect t minus 0.5 by t. Let's do it. Come on. 1 by t rect t minus 0.5 by t. See, this function, if you want, then you can write this, let's call it to be x of t. You can write this x of t to be equal to 1 by t rect, I will say it is a 1 by t common, it is t minus of 0.5. I will say like this. Okay, 1 by t rect 1 by t t minus of 0.5. Now this is 0.5 t, let's call it to be 0.5 t, so that everything comes into the picture, everything will be in the form of t. Okay, please change it to be a capital T here, 0.5 t. Now let's first take rect t. What is the rect t? Just now only I'll say that this is rect t is this one, minus 0.5 to 0.5. It is 1. First what we will do, we will go by this way. See, we will go by this way. This means that we have to divide it by 1 by t. We have to divide it by 1 by t. This means that divided by 1 by t will gives me it is 1 by t 0.5 of t to 0.5 of t. When you divide it by factor 1 by t, when you divide it by the factor 1 by t, then this is minus 0.5 t to 0.5 t. Okay, now this is what the scaling is. After that what we have to do? We have to do shift it. Shift by right by how many factor? 0.5 t. So when you shift this factor, by 0.5 t, then this becomes the signal 0 to t. Okay, so I forget that there should be t here earlier, but yes, it's okay. So this is 0 to t, and now you have to change the height also. The height is 1 by t. The height is 1 by t. So what is the representation of this function x of t? X of t is 1 by t for t greater than 0 less than capital T. See, it is 1 by t between 0 to t and 0 else. 0 else, which can be represented in this way. Okay. Now, so that's what how we can write to be the rect function. How we'll play with the rect function. Let's take another example. Suppose we have a question example. Once we formulate the theory, then the only thing is that we have to go by problems and problems and problems. Suppose I have a function which is this one. Minus 1, 1, and that is 3. Question is that write, this is xt, write xt in terms of step function. Okay, suppose we have a x of t x of t, which is this one. I want to write this function in terms of a step function. We can write it, see here. Exactly same, the reverse operation we have to do. Exactly same reverse operation we have to do. So don't you think that we can say that this is a function, we have one rect which starts from -1 having the values of 3. Okay, the function can be made, we have a one rect which is a value having a 3 and start from -1. If we subtract, let's say this function which present at 1 and having the same value 3. Okay, if we subtract, because the same thing we have did for rect function, just same thing. So we are now just breaking this into the two-step functions. We have first two-step function, we are adding it to make this function. Now we are breaking this function to a step function. So we have this, if you subtract both this function, let's say call it to be a and let's call it to be b, then a minus b is your xt. A minus b is your x of t. This means that what it is, it is 3u t plus 1 minus 3u t minus 1. So 3u t plus 1 minus 3u t minus 1 is what my x of t is. Now we can, why I have given this, though I have covered the same thing in the rect function, because we want to now synthesize any function with the help of the step function. Suppose, for example, suppose I want to write the function in terms of step function. Write the function in terms of step function. For example, this function. This function. It is -3, 0, 3. This is -4 and that is 4. Suppose someone asks you this. I want the function, problem it is, question. I want this function in terms of rect function. So can you tell me that how will you write the given function in terms of rect function? See here, look at that. Now we have, see here, how many jumps we have? How many jumps we have? Let's count the jumps. This is the jump. Surely we have a jump. Let me change the color. We have a jump. This is jump. That is the one jump, another jump. And this is another jump. So just count the jump. The number of jump is equal to number of the step function involved here. For example, if we want to write this function, then definitely xt is a 3-step function which exists at -3, 0, 3. So we have just write this one, u t plus 3. There is a one function because this jump exists at -3. The jump also exists at 0. So we have ut and the jump exists at 3. So ut minus 3. So we have a 3 jumps, therefore 3-step function will be involved. Now as far as coefficient is concerned, just simply look at the point -3. Earlier it was 0. Now it becomes a -4. Earlier it was 0, now it becomes a -4 at -3. This means that this should be what? -4, 0 becomes -4. This means that definitely this would be a -4. Now just stand here at 0. So earlier it was -4. but now it becomes a 4. This means that, tell me what value I should add on minus 4 to get a 4. Definitely 8. Yes or no? See, minus 4 it is. Minus 4, earlier we are at minus 4. We are at minus 4. And minus 4 becomes a plus 4. This means that what it is? Minus 4 plus 4 becomes a plus 8. Plus 8. Now we are at 4. Now we are at 4. Hello. Now if we are 4 and now we have to go to 0. So tell me what is the value that I have to add to the coefficient? We are at 4. What is the value we have to add to the coefficient? It is 0. It is minus 4. So we should add minus 4. So this is what my x of t is. So it is minus 4 ut plus 3, 8 ut minus 4 ut minus of 3. Is it clear? Now how will you check that my answer is correct or not? Look at this. What is the final value? Means after 3, what is the value of this function? It is 0. See, the function start from here, minus infinitive, and go up to plus infinitive. So you will go in this direction. By going in this direction, tell me the final value attained by this function. The final value is 0. So the coefficient sum must be also 0. Because these are the coefficient which is making the function to be having a jump. Okay. So the coefficient sum must be equal to 0. So what is the coefficient sum? See here. Minus 4 plus 8 plus 4 minus 4 becomes a 0. So answer is correct. Definitely my answer is correct. Let me give you one interesting problem based on this. See, let's take a multiple jumps we have. See, suppose we have this. Suppose we have this kind of function, some random function, hypothetical kind of function, though they will never ask in your gate examination. Just write it. It is a minus 10. It is a minus 5. It is, this point is minus 4. This point is 0. That point is, let's say 5. This point is 6. This point is 8. This point is 10. Let's talk about the sum. This again is minus 2. Minus 4, minus 6. This is 10. That is minus, let's say 8. This value is in between. So this should be a minus 5. And this value is in between. This should be minus 3. And that value is, after that we have a 0. Suppose someone asks you that this is my x of t. Question is that, write x of t in terms of step function. Come on, do it. I am giving you 2 minutes. Yes. Do it. I am giving you 2 minutes. Now count the jump and write the function in terms of step function. Yes, count the number of jump now. See here, how many jumps we have? See, this is jump, that is jump, this is jump, that 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 is jump. Yes or no? So these are the number of jumps we have. Just write the jumps randomly. So x of t must be what? this is jump at minus 10, so ut plus 10. Then at 5, ut plus 5. Then at jump ut plus 4, so it is ut plus 4. Then it is at 4 we have this one. Then we have 0 ut. Then ut minus 5. Then ut minus 6. Then we have ut minus 8. And then you have ut minus 10. These are the number of jumps we have. Just write the coefficient. See how we do write the coefficient. Just stand on the jump and write the upper value minus lower value. What is the upper value here? Upper value means after the value of jump and before the value of jump. So at this point, see at this point, what is the value? Minus 2, minus 0. Should be minus 2. Change the color. This should be minus 2. This should be minus 2. At this point, what is the upper value? Minus 4. Minus 4, minus 1, minus 2 means it is minus 2 again. At this point, see here, at minus 4, what is the value? Upper value is minus 6, lower value is minus 4. Again minus 2. Upper value minus lower value. See, what is the upper value? Minus 6, lower value is minus 4. Minus 6 minus 1 minus 4 becomes plus 2. Here, see here, what is the upper value? 10. What is the upper value? At 0, what is the upper value? 10. And what is the lower value? Minus 6. 10 minus 1 minus 6 becomes plus 16. See, at 0, if you stand here, what is the value after this one? What is the value before this one? See, ut minus 5. At this point, minus 8, minus 10. See, at this point, what is the value? Minus 8. Before value, 10. 8 minus 10 is minus 18. It's minus 18. At 6, what is the value? Minus 5 minus of minus 8. It is plus 3. Plus 3. See, minus 5 minus of minus 8 becomes plus 3. At this value, minus 3 becomes minus 3 and minus 5 are the values. So it is plus 2. And at 10, 0 minus of minus 3, it is plus 3. So this is what my x of t is. This is what my x of t is. Simple. Okay. Just for practice, I have given you this problem. Nothing to do with your gate examination. If you add all the coefficients, again the value should be 0. See, what is the final value? Final value is 0. So this means that the coefficient addition would be 0. So what? See, minus 2, minus 2, minus 4, minus 6, plus 16 is now 10. This is minus 8. Minus 8 plus 3 minus 5 and plus 5 becomes 0. Yes, it is. Okay. So this is what nothing but this function. And so again one question, plot 3u t plus 4 minus 6u t plus, let's say, plus 9u t minus 6 minus 6 u t minus 10. Suppose someone asks you this, can you do it? 6u t minus of 10. Again, this is a very simple problem. Easily you can do it. Just do it in your home. I think that the function that you will get is this one. See, is this 4 at 6 this one, and this function you will get. Check it. This is at minus 4. This is 0. This is 6. This is 10. This should be 3. This should be minus 3. And this should be 6. and this is 0. Check it. Check, this is the homework for you. Check, this should be the answer. Now, this is the function. Now, this is the one application of step function. Another application would be, see here, suppose I have x of t. X of t is plotted. This is a random x of t. Suppose we have this one, starting from minus infinity plus infinity. Minus infinity plus infinity. Xt limit is, xt is some function from minus infinity to plus infinity. If, let's say, yt is xt into u, let's say t minus 3, a, b, yt is x of t into u minus t minus 3, c, yt is x of t into, let's say, u alpha t plus beta, and d, yt is x of t into half u minus 3t plus 9. Find limit of existence of yt in each case. You understand my point or not? See here, x of t is a function, random function is given to you. Only thing is that it has some, let's say, existence from minus infinity plus infinity, and someone asks you that now what I'm doing is that I'm multiplying x of t with ut minus of 3, u minus t minus 3, u alpha t plus beta, and xt into half u minus 3t plus 9. I want the limit of existence of yt. I want the limit of existence of yt. That's what the simple question is. Let's do it. See here, what is u alpha t plus beta? For example, suppose someone asks you that is u alpha t plus beta. But before that, let us first take u alpha t. What is u alpha t? Now you know that ut is this one. That's what my ut is from 0 to infinity. This is ut. So if someone asks you what is u alpha t, then this should be 0 to infinity divided by alpha and divided by alpha. So this is nothing but my same thing. See, same thing. But let us consider that is only possible when alpha is greater than 0. But what will happen if I am saying that alpha is less than 0? Or example, u minus 2t. For example, see here, 0 divided by minus alpha becomes same thing, but infinitive divided by minus alpha becomes a minus infinitive, yes or no? So what I am saying is that if you will have u minus 2t, then don't you think that I will get this function? See, when you divide it by minus 2, you will get the same thing, but infinitive divided by minus 2 is minus infinitive. It is from minus infinity to 0. Minus infinity to 0. This means that what I am saying is that if alpha is less than 0, then u alpha t becomes u minus t. U alpha t becomes U minus t. And if alpha is greater than 0, then U alpha t becomes a UT. Simple. U alpha t becomes a UT simply if alpha is less than 0. This means that U minus 2t, U minus 2t is just a U minus t. This is what a U minus t is. This is what the U minus t is. Okay. This means that, see here, if someone asks you about scaling factor, then scaling factor on UT will change the sign. Only scaling factor, I'm saying, not shifting factor, will change the sign only and only when alpha is less than 0. Alpha is greater than 0, there is no sign. Otherwise, it will reverse. And I told you about the reversal. Reversal means flipping around y-axis. Reversal means what? Flipping around y-axis. Simply. Now let's talk about U alpha t plus beta. What is U alpha t plus beta then? U alpha t plus beta can be written as U alpha t plus beta by alpha. Okay. Start from this one. Depending of course on the values of alpha. Let's consider alpha to be positive. Alpha is greater than 0. So U divided by alpha will not make a difference. The only thing is that the signal shifted by minus beta by alpha. Okay. The signal shifted by minus beta by alpha. Left shift by minus beta by alpha. So for example, if you have U of minus 2t plus 4, then can you tell me what is the limit of existence? See, it is U taking minus 2 and it's a t minus of 2. So first what you have to perform? You have to perform on UT. So start with UT. This is UT. This is UT. Now what you have to do? First reverse it. Change the pen sign. See, this is U minus t. Now this 2 has no effect. This 2 has no effect. Because if you divide by 2, 0 or minus infinity, it will be the same. And now the signal shifted to minus 2. This means that the signal becomes this one, see. The signal is right shift by 2. So what is the limit of existence of this function? It is from minus infinity to 2. What is the limit of existence of this function? It is a minus beta by alpha to infinity. This is what the limit of existence is. And what is the value of this function? It is 1. Now come to this function. Now come to these questions. See here. Ut minus of 3. You know that. See here. If the function is this one, x of t, and I have to multiply it by ut minus of 3, ut minus of 3 which starts from 3, then everywhere since the function is 0 and the value is 1 here, everywhere since the function is 0, the function becomes a 0, but it will exist from 3. So what is the limit of existence of this yt? Yt exists from minus 3 to infinity. Sorry, plus 3 to infinity. Plus 3 to infinity. Very simple. Acha, what about this one? Suppose we have x of t. This was a and that was a b. And it is multiplied by, this is ut minus of 3, right? Now I want u, let's change the sign. Let's take in the first page. B. I want x of t, which is this function, multiplied with u minus t minus 3. What is the limit of existence? First plot u minus t minus 3. See, first we have to take minus common. U minus, it is t plus 3. Start with ut. This is ut. First reverse. And then left shift by 3. See, it is plus here. Left shift by 3. This means that this function will be this one. That's what a u minus t minus 3 is. Okay. Those who have not covered the last class, please go and cover this one. Last to last class, I have told you about what is the meaning of shifting, scaling and reversal combined operations. Now what you have to do is you have to multiply both this function, and this function is completely 1. After -3 it is going to be 0. After -3 it is going to be 0. This means that the limit of yt, which is xt multiplied with u minus t minus 3, is minus infinitive to -3. Hello. But look at the wonderful use of this step function. See, whenever any function is multiplied by the step function, then according to the limit of a step function, the limit of this function will change. The limit of this function will change. So that's what the meaning of step function. Okay. So that's what a very, very interesting thing, very, very important thing that you have to take care of while dealing with the step function. Is it clear? So I think all the example you can make. Now this I covered, alpha t plus beta also I covered. What about this one? See, if that I already told you, minus 3t plus 9, u minus 3t plus 9. Let's take this function also. Let's take b cover. Let's cover d. D was x of t multiplied with 1 by 2 u minus 3t plus 9. And what about x of t? X of t is this function. This is what my x of t is. Good evening, Vijay. Okay. Now the point is that, see how hello. Hello. Sorry for the disturbance. Yeah. Okay, fine. Sorry. How long it was there? Means how long the complete mic was not there? Vijaya, can you tell me? I think I have checked in starting, but not in between. The whole lectures got disturbed. Okay, 30 to 40 seconds. Fine. Thank you very much. Thank you, Vijaya. Thank you. Sorry. So what, before 30 to 40 seconds, what I was telling you is that, see here, that this step function is nothing but my simply used to change the limit of this function. So here, whatever be the limit of this step function we have, according to the function limit of x of t will change. Okay, now this means that u minus 3 and t minus of 3, u minus 3 is there, t minus of 3 is there, and this 3 will not make any difference. Now the complete signal shifted to 3. This is what? This is done, this is done, this is done. And now what I have to do is that I have to multiply it by x of t. So the x of t is this function multiplied by this function. But now this time value will also change. Value, what is the value? Value is 1 by 2. Listen, value is 1 by 2. Hello. Value is 1 by 2. This means that the value will not change. Value is changed by 1 by 2. So this will, what about this function? See, the function will now, definitely a jump will exist at 3 and having a value of 1 by 2. So it is x of t is 1 by 2 multiplied by the values, whatever it is, 1 by 2 multiplied by the values for t minus infinitive to 3. For t minus infinitive to 3. That's a very, very important point. So this is the one very interesting application of x of t. This is one very interesting application of x of t. Okay. Any function when multiplied by a step function, then the limit of this function will change. Limit of that step function will change. One thing. Okay, so what I have covered till now, I have covered that how the step function is modeled, how the step function is used in our day-to-day life. What do you mean by transient part, steady state part? These kind of things I have covered. What is the practical step? What is the ideal step? These kind of things I have covered. And then I have now, after that is for the last 1 hour, I am dealing with the step representation of a function. What is the rect function? What is the this kind of function? That is how you multiply with the function x of t and how the limit will change. This kind of issues I have dealt with so far. Now let's come to the one very interesting application of the step function and define another function. Okay, so let's consider, let's say I have a function, again plot. Let's say I have ut plus u minus t. I want this function ut plus u minus of t. Suppose I want to plot this function. Now let's take it. What is ut? Ut is this function, you know that. It is 1. And u minus t is this function. Okay, come on. If you add both this function, then see in the second quadrant it is completely 0, 0 plus 1 is 1. In the first quadrant it is 0, 0 plus 1 is 1. 0 plus 1 is 1. Hello? But what is the value? See here, what is the value at this one? What is the value at this one? The value at the origin at t is equal to 0, at t is equal to 0, just now I have told you in the beginning that the value at the origin is not 1, guys, it's a half. Yes, no, just see the lecture from the beginning. See, what I am saying is that the value at discontinuity is not 1. The value at discontinuity is not 1. The value at the point of discontinuity is the average of the value. Ut, if you want to write, then ut is 1 for t greater than 0, is 0 for t less than 0, and I told you it is a 1 plus 0 by 2 at t is equal to 0 according to Gibbs phenomena. Here also, see, whenever there is a point of discontinuity, the value is not the value is not equal to the same value, because ideally the value is not defined. Here also it is 1 for t less than 0, it is 0 for t greater than 0, and again it is a 1 by 2 for t equal to 0. That is what the important point you have to understand. And when you add both this function, then since 1 by 2 is this, 1 by 2 is this, and so 1 by 2 becomes a 1, and this function is a complete 1 everywhere. So what is the most important point you have to consider here is this one. See, this function, this is a function that you have to consider it. The value at discontinuity is not equal to 1, it is a 1 by 2. So this is equal to how much? 1. In general, any value, let's say call it to be alpha, any value alpha can be written as, alpha is a constant, can be written as alpha ut plus alpha u minus t with the same fact. With the same fact. Any value, let's say 5. 5 can be also written as, yes, this is what the DC signal is. That's what the meaning of DC function is. So any function DC can be written in terms of step function. Alpha ut plus alpha u of minus t. Okay, alpha ut plus alpha u of minus t. That's what the meaning of DC function 1. Now let's consider this one. See, instead of what I'm doing is that, see, what I'm doing is that instead of taking, let's say, plot ut, okay, minus u minus t. Ut u minus t minus u minus t. In this case it is what? See here, it is what? See here, ut is this function and u minus t is this function. And when you subtract this function, then 0 minus 1 becomes a minus 1. And 1 minus 0, here 1 it is 1. 1 minus 0 becomes a 1. Don't you think that I will get this function? Hello? Don't you think that I will get this function? So it is 1 when t is greater than 0. It is minus 1 when t is less than 0. But what is the value at t is equal to 0? Hello? At t is equal to 0. At t is equal to 0, don't you think that again I have a jump? Again I have a jump. So what we will write? We will write 1 minus 1 by 2, which is 0. So at t is equal to 0, the value is 0. At t is equal to 0, the value is 0. At t positive, it is 1. At t negative, it is minus 1. This is a function which is denoting the sign, which is representing the sign of t, which is a sign of t. This function denotes the sign of t. This means that when t is positive, it gives you 1. When t is negative, it gives you minus 1. And when t is 0, it is 0. This means that this function is popularly known as Signum function or sign function. Okay? This function is popularly known as Signum function. It's a very, very famous function. It's very, very famous function, which we will say that this is what the Signum function is. Okay? So Signum of t is 1 when t is greater than 0. It is minus 1 when t is less than 0, and is 0 when t is equal to 0. That's what the meaning of Signum function is. Signum function. Yes. Now let's take one interesting part, that what do you mean by Signum xt then? What is Signum? T is, okay, fine. Signum t I find that is a 1 for t greater than 0. It is minus 1 for t less than 0. It is 0 for t equal to 0. Okay, fine. What is Signum of x of t? Signum of x of t. See, Signum of x of t, it denotes, see, Signum t denotes the sign of t. Then Signum of x t denotes the sign of x of t. So it is It is 1 when xt is greater than 0, and it is minus 1 when xt is less than 0, and is 0 when xt is equal to 0. Same definition. Same definition. Same that whenever the x of t is greater than 0, whenever the x of t is greater than 0, it will give you 1. Whenever the x of t is less than 0, it will give you minus 1. Whenever the x of t is equal to 0, it will give you nothing but my 0. Okay, that's what the meaning of signum of x of t is. Okay, then tell me what is signum of sine 20 pi t. Let's say 10 pi t, I am saying 10 pi t. Signum of sine 10 pi t. What is signum of sine? So it is 1 when sine 10 pi t is greater than 0. It is minus 1 when sine 10 pi t is less than 0, and it is 0 when sine 10 pi t is equal to 0. That's what the meaning. So let's plot it. So let's plot it. Okay. So okay, now see, this is sine function. Sine function we can be plotted as this one. See, this is sine function. Okay, this is sine function. And what is the time period? Time period can be easily found. See, what's the time period of this function? See, omega is 10 pi. Those who don't know, just take it as a fact. Omega, this value is omega, sine omega t. So this means that t is 2 pi by omega. This means that it is a 2 pi by 10 pi, or you will say it is 1 by 5. 1 by 5, this means that it is a 0.2. 0.2. So this means that total time period is 0.2. So from here to here, the time period is 0.2. This is 0.2. This means that this should be 0.1. This should be 0.2. This point. Okay. This is 0.2. This should be 0.3. This is 0.4. This should be minus 0.1. This is minus 0.2. And now this is passed through this function. Okay, this function. This is passed through this function. What you will get? See here. See here, whenever sine 10 pi t, look at the definition, whenever sine 10 pi t is greater than 0, sine 10 pi t is greater than 0, this means that this is greater than 0. See, look, this is greater than 0. Whenever sine 10 pi t is greater than 0, you will get 1. So this means that I will get 1 here. This is 0. This is 0. Let us take this one. See, this is 0. So I will get 1. And then I will get minus 1. Again I will get 1. See, it is greater than 0. For this reason I will get 1. Again I will get minus 1. Again I will get 1. Same here in the negative reason also. See here, it is less than 0. This means that I will get minus 1. Plus 1. This is minus 1. And this value is 0. This is 0.1. And this is 0.1. Yes, this is 0.2. So that is what, this is what, this signal is Signum sine 10 pi t. This is Signum t. And that is sine 10 pi t. So don't you think that a sine function get converted into, hello, a sine function get converted into a step function, hello. So it is behaving like what? It is behaving like a comparator. It is behaving like a comparator. See, what is the function of comparator? What is the job of comparator? Come on. The job of comparator is very simple. So it is V in, it is VTH, it is plus, it is minus, it is VCC, it is minus VCC. So when V in is greater than VTH, you have VCC. When V in is less than VTH, it is minus VCC. And when V in is equal to VTH, it is a threshold. It will maintain the threshold level. It will float the output. So see, what is the threshold here? Threshold is nothing but my 0. So when function is greater than 0, gives you 1. When function is less than 0, gives you minus 1. And at this point, see here, at this point, at let's say this point, the functional value at 0, this, see, the functional value is 0. Why? Because the average. Why? Because the average here. If you take the average at this point, then the average becomes a 0. 1 minus 1 becomes a 0. That's what the meaning of Signum 𝐿 is. That's what the hope this point is clear to you. Is it clear? This is a beautiful example, beautiful application of step function. This is a beautiful application of step function. Okay. So at this point, what is the average here? Average is 1 minus 1 becomes a 0. Now listen carefully. See here, I am giving you the homework. Homework, plot u of sine 10 pi t, where u unit step function, where u is a unit step function. Okay, so this is what we talk about today. So what we have covered in today's class is, see here, we have covered mainly the step function. So we have covered each and every aspect of a step function, and we have covered mainly application, in which the applicational part is rect, Signum, and various others functions. Okay, so if you, this is what the whole lectures of CTS step functions, though DTS step function I will cover in just nutshell, just in a quick manner, but the point is that the step function is overall clear. Okay, and if you just covered the complete lecture from, that is starting to beginning, starting to ending, then beginning to end, then every doubt of step function will be clear. So that's what the step you must know. Is it clear? Hope I'll clear each and every doubt of nothing but my this class. Is it clear? And with this, thank you very much. Thank you. If you have a doubt, I am here for just 1 minute, 1 minute, 2 minutes, depending on your doubt. Do ask the doubt, feel free to ask any doubt. Yes, I don't think that there is a doubt. Students are not attending, what kind of doubt we have? Okay, fine. Maybe they will attend in the last. Thank you very much. Thank you.